Okay, so make sure you have one of these papers, and you're going to do the notes for Newton's laws of motion. So again, we're talking about Newton's laws. And there are 3 laws. So I'm going to move on to first law. First law, and then we'll talk about obviously the second law and the third law. So Newton's first law. Newton's first law. This is the law that states that an object in motion stays in motion, and an object at rest stays at rest. Until another force acts on it. So a lot of people remember this part, but then I feel like a lot of people forget this. Unless another force acts on it. For the example in circular motion in the pie pan, so in this pie pan, we should see this on the lab. So you already saw this on the lab. When the marble went around in a circle, once it no longer has the wall pushing it in a circle, it's just going to continue on in a straight line. All right. So this is the reason why you wear seatbelts. This is the reason why it doesn't just continue going in a circle, but it goes in a straight line. At this very moment, the marble's actually going in this direction adjacent. If it would have been here, then the marble would have been, like if this was where the pie pan was cut out, then it would have gone straight out adjacent to the pan. So for your example here, just go ahead and write down that in circular motion, object must have a force keeping it in a circle, keeping it in a circle. The other example would be like if you're going on a curve in a street and you hit the ice, your car is going to do the same thing. If you're going in a curve and now you hit a patch of ice and you no longer have friction keeping you in a circle, because that's what keeps you moving in a circle, then you're going to move in a straight path. Okay, so that would be another example of this. So that's Newton's first law. I'm going to move on to Newton's second law. Newton's second law states that when the force that the force and the acceleration are directly related. So if you push something with more force, then it's going to move faster. But the mass and the acceleration are inversely related. So this is just stating that the relationship between force and acceleration is directly related and the relationship between mass and acceleration is indirect. This is actually given to us in an equation, F equals ma. And F stands for force. And this is in newtons. So remember, every time I put something in parentheses, that's the unit. The mass of this, the M stands for mass. And mass is in kilograms. And the acceleration is still going to be in meters per second squared, like you learned in the past. Okay? And I like this picture because it kind of shows the relationship of these two. So force and acceleration are obviously directly related. So if you have something and you push it with more force, then it's going to accelerate with more acceleration. However, in this case, we have a basketball. So the basketball has very little mass. So small mass means a larger acceleration. Okay, so low mass means larger acceleration. However, if we now have a car that we have to push, this one's going to require, if you use the same amount of force, right, because this little arrow is about the same. If you use about the same force, this one's going to have a really small acceleration, because when you have a larger mass, higher mass, your acceleration is going to decline. So acceleration is going to be lower. All right, and that brings us to Newton's third law. And for Newton's third law, it said that for every action force, there is an equal and opposite reaction force. Okay, so in the case of these balloons, there's two forces. This balloon is going to move upward because the air is being pushed down. Okay, so if the air on the balloon, air in balloon pushes down, the balloon will move up. We are going to focus on this one mathematically, and these questions are going to be conceptually. So the next practice you're going to do is F equals MA sample problems.